Okay, everybody, welcome back to Unit 3, Lesson 1. We're going to be graphing linear relationships. So we have this word linear, meaning a straight line. Your answers are going to be straight lines. We're going to use a table of values initially. This is part B. We're going to begin to start looking at non-proportional relationships. We'll start easy with positive coefficients. A coefficient is the number multiplying in front of your variable x. That's your coefficient. So we'll start with positive. Remember, the line will be up to the right and down at the left if it's positive. Negative slopes are the other way. The left is up and the right is down. Okay, let's take a look at where we were prior to this. In the earlier lesson, Part A of Unit 3, Lesson 1, we graphed linear equations using a table of values, but we only looked at equations that were proportional, which meant that, for example, we had y equals 2x, 2/3 x. There was no trailing number here. What happens then is when you have 0 for proportional relationships, the 0 would multiply times the 2/3 and give you 0. Initially, the input values, the x values, were given to you. You can see that this one is going up by 3 every time, plus 3. And the reason why those numbers are chosen is that they are multiples of 3. So you have this 3 in the denominator, and when you multiply 2 times -9, because you substituted it in, you get -18/3, and then that's a nice reduction and you get an integer out, which makes the values easy to graph. So this is a good strategy here to choose multiples of 3, which we have here, giving us integer answers and simple to graph. Again, in Part A, we just had no b, we just had y equals mx. So all of our graphs went through the origin. And then with a 2/3 less, that's less than 1. So we have a little flatter. When the integers are large, then you get a steeper graph. So for example, the very first graph you would have done, y equals 2x, this would have been a lot steeper. It would have been like this. Okay, y equals 2/3 x, you can see, is much flatter. Okay, so we're still going to go through this objective. We're going to choose input values. Sometimes I'll give them to you initially based on the coefficient. We're going to look at the coefficient. And then we substitute the values in and we solve for y. We write that answer as an ordered pair. We graph the points and draw the line. Now, if the points don't line up, then there is an error somewhere, and you need to find that error. You recalculate and plot the correct point. Okay, let's take a look. We'll start with something very simple. So just like in the Part A, we had y equals 2x, but now we have y equals 2x, minus 4. So in this situation, when you put the 0 in, substitute in here, y equals 2 times 0 minus 4, you're multiplying, you get y equals 0 minus 4, which is just -4. So this graph's going to go through 0, -4. And when you plot that, it's here. This is going to be the basis for the next lesson. If you can find a simple point, which we do here, this is called a very important point called the y-intercept. Later on, we can use the y-intercept as a starting point. So in the next lesson, we'll use this as a starting point. And in the next lesson, we'll start here, and then all we have to do is look at how the line changes, which is the slope. The slope of the line, as you can see here, the letter M is the slope of the line. It represents the rise and the run of the line. So in this situation here, the slope is equal to 2, but we need it to have two parts. So we would write it as 2 over 1, which means it would go up 2 and right 1. We'll check that out as we do the rest of the table. We can see that we also know the y-intercept is 0, negative 4. The trailing number is when x is 0, you get a negative 4. Okay, so now you're just substituting in however you like to do it. You could do it one row at a time. You could do it all the numbers at a time. I'd prefer to just write them all. Later on in high school, you can skip this column and just do the x and the y column, and you can skip this column. But for now, we need to practice. This is negative 6 minus 4, negative 4 minus 4, negative 2 minus 4, 0 minus 4, 2 minus 4, 4 minus 4, and 6 minus 4. So again, this is going to be great practice for you to practice adding integers together. This is the negative 6 minus 4. The answer is negative 10. Think about if you are 6 feet under the water and you dive down 4 more feet, you're going to be 10 feet under the water. And the same thing here. Negative 8, negative 6, negative 2, 0, and 2. Now let's take a look at what exactly happened here. Our inputs are changing plus 1 every time. So our inputs are going up by 1. Look at our outputs and look at this coefficient is 2, and notice that we're changing plus 2 every time. So when you're dealing with lines, you're going to form patterns. And so then we could just graph our points. Negative 3, negative 10, negative 2, negative 8, negative 1, negative 6, 1 comma negative 2, 2 comma 0, and 3 comma 2. So we're on a good roll right now. And then another check to practice shows you that you are putting the points in the right spots. From the origin, these are locations, single locations, 3 left, 10 down. There's your first point. Let me push this up just a touch. Negative 3 comma negative 10. Negative 2, negative 8, negative 1, negative 6, 1, negative 2, 2, 0, and 3, 2. Again, any mistakes will be found and caught here as I lay my straight edge down. The points have to line up, and then I just top it off with a little arrowhead on both ends. Slope of 2, notice it's nice and steep, right? Slope of 1 would have been here, less than 1 gets flatter, so fairly steep. Passes through 0, negative 4. So that's the simplest case. We have an integer for the slope, pretty simple point there. And then we get to a little bit more complicated case. Notice that we have these are given, these independent input values. I chose these ones for you. They're going by 3s, plus 3 every time. So if I'm looking at the pattern, it's plus 3, etc., etc. And boy, this trailing number, though, is a little bit confusing here because I have it trailing minus 2.5. It's going to be a little trickier as an 8th grader to put this in. Let's see, y equals 2/3 times negative 9 minus 2.5. Okay. Okay, well, I know that I want to multiply because I have to follow order of operations here. So what is order of operations? It tells me I have to do things in a certain order. Multiply and divide. Add and subtract is last. So multiply and divide is before add and subtract. And we work left to right. For the most part, parentheses and exponents. We don't have any parentheses. We don't have well, we do have a parentheses, but it's simply just a multiplication in this situation. But we're going to do this multiply and divide before we have to do the subtraction. That's last, right? Subtracting 2.5. So I'm just going to focus here on my 2 times. That's going to be negative 18 over 3 minus 2.5. Okay, well that's negative 6. Negative 6 minus 2.5 is negative 8.5. So my first point is negative 9, negative 8.5. And I know it's going to change by, because these are changing by 3, but I'm factoring out the 3. These are going to change by positive 2. So my next point should be at negative 6.5. Negative. So every time adding 2, this should be negative 4.5. And then I can find the pattern, and it makes my life a little bit easier. Let's graph that first point here. Negative 9 is here, if I go from the origin. And negative 8.5 is actually halfway between these are called lattice points, these corners where the things meet. So if I go from negative 9, which is left, and then I go down negative 8 and negative, it's between negative 8 and negative 9. So I have, I'll just write it to the left, negative 9 comma negative 8.5. And I'm going to keep doing my math here. Y equals 2/3 times negative 6 minus 2.5. That's negative 12 over 3 minus 2.5. Negative 4 minus 2.5. So my next point was negative 6 and negative 6.5. And it's going to continue. 2/3 times negative 3 minus 2.5. That's negative 6 over 3 minus 2.5. Negative 2 minus 2.5. Okay, the next one is 2/3 times 0 minus 2.5. Anything times 0 is 0. And 0 minus 2.5 is negative 2.5. So my next one, negative 0.5, then 1.5, then 3.5. Again, it's changing by plus 2 every time. This is the change here. And because we pick by 3s, that's why it doesn't change by 2/3. All right, y equals 2/3 times 3 minus 2.5. That's 6/3, which is 2 minus 2.5. 2/3 times 6 minus 2.5. 2/3 times 9. So I'm going to do, that's 12 over 3 is 4 minus 2.5. 18 over 3 is 6 minus 2.5. Now I'm on the positive side. It's pretty easy. 0, negative 2.5. 3, comma, negative 0.5. 6, comma, 1.5. And 9, comma, 3.5. So now all I have left to do is to graph this thing. Negative 6, negative 6.5. Okay, well here's negative 6. Negative 6.5 is halfway between negative 6 and negative 7. Negative 3, negative 4.5. You'll know if you did it wrong because 0, negative, it won't line up. And once you've 3, negative 0.5, 6, 1.5, and 9, 3.5. The ultimate test, of course, grab your straight edge, and if your dots are not aligned, you've done something wrong. So you go back to your table and find your mistake. A beautiful line is done, and you are set. If you want, you should label them all. It makes it look a lot nicer. 1.5, sorry. 3, negative 0.5, 0, negative 2.5, and the other two. Okay, so that was the third one. Now you get to another problem. Okay, similar thing. You're asked to graph this with the table of values. Now we need to look at the numbers in the coefficient. The coefficients here, the slope, is 3/4. So we have this 4 in the denominator. That's the multiples that we need to pick for our inputs. Remember, input values are independent. You get to pick them. The outputs are dependent on what you pick for the input. So it's really important to do strategy. And since we're going to be dividing by 4, we want to pick multiples of 4. Now you could start on the negative side or the positive side. I tend to start on the negative side. Negative 12, negative 8, negative 4, 0, 4, 8, and 12. Notice that I didn't go negative 12, negative 8, negative 4, 0, 12, 8, 4. I want to go along the number line and look at how the number line goes. Negative 12, negative 8, negative 4, 0. Next is 4, then 8, then 12. Okay, now I'm set. These are changing by 4. That's going to make the y's change by the numerator by 3. So I get y equals 3/4 times negative 12 minus 3/2. Don't get freaked out by the fraction. We're still doing multiply and divide before we add and subtract. So we still have to do the 3 times negative 12, negative 36 over 4, minus 3/2. That's negative 9 minus 3/2. Well, what is 3/2? It's 1.5. So this is going to be negative 10.5, which is, or I could make that into 18. I could make that negative 18 over 2 minus 3/2, which is negative 21 over 2. Or another way to write that is negative 10.5, negative 10.5. And then it's going to change by 3 every time. So this is negative 10.5. Okay, y equals 3/4 times negative 8 minus 3/2. That's negative 24 over 4. That's a 4. Minus 3/2. That's negative 6 minus 3/2 is negative 7.5. I can see that this is adding 3. So as you start getting a pattern and you understand this, you can start adding 3 each time. So this is negative 10.5. It's going to change by 3. Negative 4.5. Negative 1.5. Positive 1.5. By 3 is 4.5, then 7.5. So we have our pattern. If you feel more comfortable writing it out, that's fine. You can do cross-canceling here. You know that's negative 12 over 4, which is negative 3 minus 3/2, which is negative 4.5. Here's a 0 minus 3/2, which is negative 3/2, which is negative 1.5. So we're expressing things as your choice. You can express them as fractions. You can express them as decimals. When graphing, it's a little easier to express your outputs as decimals. It's a little easier for graphing. But if you like fractions, you can leave them as fractions. You can put them all over 2, negative 21 over 2, and etc., etc. So we have our pattern. We're just going to finish this up, negative 4, negative 4.5, and graph it. Now it's going to be relatively flat because it's between 0 and 1. 0, negative 1.5, 4, 1.5, 8, 4.5, and 12, 7.5. I want to start with the positive here. 12, 7.5 is in between 7 and 8. 8 and 4.5. 4 and 1.5. 0, negative 1.5. Negative 4, negative 4.5. Negative 8, negative 7.5. And negative 12, negative 10.5. Again, you have your check built into it. Take a look, put your ruler down, do the dots line up. If your dots aren't lined up, you've got a mistake and you have to go back and find it. And there's your next line. At least label some of the points. Negative 12, comma, negative 10.5. And here we have 0, negative 1.5. The y-intercept, most important. It's called the y-intercept because this is the y-axis. And it's where it intersects the y-axis. And it's a great starting point. And then you're going to continue. You take a look at the next problem. This one's a little easier, but you have free independent choice. This is your independent variable, the one that you pick. Now, of course, you want to look at the denominator as being 5s. So what would be a smart idea to pick for your input values? Multiples, choose multiples of 5. Now you might say, okay, well, positive 15 and negative 15 don't fit on this graph, Mr. Garrigus, and that's true. So you're going to have to graph the points, these points first, and then you can place your imagination out and do your negative 15 and positive 15. Okay? So I would start with the negative 10. Y equals 3/5 times negative 10 minus 5. Negative 30 over 5 is negative 6 minus 5 is negative 11. So they should go up by 3 every time. Okay, once you've done the positive, remember positive, 3/5, so all your graphs are going to be positives. They're all going this direction. So when we get to negatives, which is the next part, your graph's going to go the opposite direction. So now we have y is equal to negative 3x minus 5. Okay, these are all changing by plus 1. Plus 1, plus 1, plus 1, plus 1. But how are the outputs going to change? These are all changing by plus 1, and then they're all being multiplied by minus 3. So now we're going to be subtracting 3 as we skip. Every time we skip here, minus 3, minus 3, minus 3, minus 3. Now I know that going forward, I can see what we got here. Y equals negative 3 times negative 3 minus 5. I multiply first because of order of operations. I get positive 9 minus 5, which gives me a positive 4. Let's try the next one. Negative 3 times negative 2 minus 5. That's 6, because it's a negative times a negative is a positive 6. So be really careful. You're going to get lots of double negatives here that makes it positive 6 minus 5 is 1. Y equals negative 3 times negative 1 minus 5. Two negatives multiplying, positive 3 minus 5 is negative 2. Notice it changed by 3. Minus 3, it's going down. Y equals negative 3 times 0 minus 5. 0 minus 5 is negative 5, and now I got my pattern going. Negative 8, negative 11, negative 14. That'll be off the graph. Y equals negative 3 times 1 minus 5. Negative 3 minus 5. Negative times a positive. Negative 3 times positive 2. Lots of more places to make mistakes here. Negative 3 times positive 3 is negative 9. And now I just need to graph these. Negative 3, 4. Negative 2, 1. Negative 1, negative 2. 0, negative 5. 1, negative 8. 2, negative 11. And 3, negative 14. Okay, negative 3, negative 4, negative 2. Oh, I already made a mistake. So, it's negative 3, positive 4. So that's good I caught that. Negative 3, positive 4. Negative 2, 1. Look how steep this is. It's negative 3, so it's very steep. Negative 2, 1. Negative 1, negative 2. 0, negative 5. 1, negative 8. 2, negative 11. I'm going to stop there because I'm off the grid, but it is negative slope, so my line is going the other direction. Like so. If I had to put my negative 2, negative 14, that'd be about right here. Negative 3, I'm sorry. Somewhere about there. Okay, so that you're going to continue on that and have some slightly more challenging problems like this one. Again, you're going to end up with two negatives here. Y is equal to negative 4/3 times negative 9 minus 3.5, okay? That's positive 36 over 3. That's going to be 12 minus 3.5 is 8.5. And then, so it should be going down by minus 4 every time. This next one should be, because we're going by 3s, adding 3. So this should go down by 4. So the next one should be 4.5. Y is equal to negative 4/3 times negative 6. That's going to be negative 24 over 3 minus 3.5, positive 24 over 3. 8 minus 3.5 is 4.5. Negative 4/3 times negative 3 minus 3.5. That's positive 12 over 3, which is 4 minus 3.5. That's a decimal point. Is 0.5, and that fits our pattern. Our pattern is minus 4 every time. So the next one should be negative 3.5. And we have 0 minus 3.5 is that, negative 3.5. Again, minus 4, minus 4. What's next? Negative 7.5, negative 11.5 as we subtract 4, and then 1 off of completely off the paper. So we don't need to worry about that one. Y equals negative 4/3 times 3 minus 3.5. Okay, that's going to be negative 12/3 is negative 4 minus 3.5. Yep. Times 6. That's going to be negative 24/3 minus 3.5. That's negative 8 minus 3.5 is negative 11.5. So I'm almost done. Pretty close now. I just need to graph it. And now I'm just plotting these points. I go left negative 9, positive 8.5. It's halfway between 8 and 9. Negative 6, 4.5. Negative 3, 0.5. That's an easy one. Zero, negative 3.5. Very important point, the y-intercept. You can see that we would want to build a more efficient or easier way to graph these than doing a table of values, because it starts to become very tedious. 3, negative 7.5. And a table of values. So our next method will just be slope intercept. 6 and negative 11.5 right there. Line them up and draw your line. Does it look right? Yes, it's going. If I have my left hand up and my right hand down for negative slopes, you can see that I'm traveling along. If I was to draw a person with a left hand up and their right hand down, it would form this type of a line. Remember, it's greater than 1 because this is negative 1.3 basically. All right, then you're going to check here. So what would your strategy be on the next one? This one's a little harder. You can change this number. If you want to change that, you could change it to y equals negative 3/5 x minus 2.5. That will make your life a lot easier than having to deal with this fraction right here. And again, you're going to want to choose multiples of 5. And why? Why would you choose multiples of 5? Well, it's because you're being divided by a 5 here. So you're going to pop these in. Negative 15, negative 10, negative 5, 0, 5, 10, and 15. Those would be your values that you choose. And then solve for y. Remembering that these are going to go down by minus, since you're doing multiples of 5, these are going to go down by minus 3 every time. So once you get that first number, you can actually start filling out the pattern or checking your work. Your checking work will come out here. Your checking will also be in your graph. Okay, and then you're going to be assigned one problem to be turned in. Notice that this is in a decimal form, but you need to be able to write the equivalent of this in a fraction form. That's negative 7. Think of negative 75 over 100. There's 25. They both share 25. You got 3 and 4. Y equals negative 3/4 x plus 3. So here, what are you going to choose? Multiples of what? Multiples of. You're looking at the denominator. You want multiples of 4 here. In order, going across. So if you start by negative 12 here, then it's negative 8, negative 4, 0, 4, 8, 12. You're traveling always equidistant. In line, in order. Okay. And this is going to be the last one. You'll have to take an image of this final graph here and turn that into Google Classroom for your points for the lesson. Good luck.